ThinKom's truck-mounted microwave gun fries drones at U.S. Army test. A California company better known for building antennas that connect aircraft to satellites has quietly entered one of the most competitive markets in defense, and at the U.S. Army's recent cross-domain fires concept-focused warfighting experiment, its mobile high-power microwave system showed up mounted on a pickup truck cued by Echodyne's EchoShield radar ready to fry drone electronics without firing a single round. ThinKom Solutions, headquartered in Hawthorne, California, announced its entrance into the high-power microwave-directed energy weapons market in August 2025, developing systems for counter-UAS, integrated air and missile defense, and other counter-electronic missions. The move was not a pivot so much as an extension. The company spent more than 2 decades building phased array antenna systems for satellite communications, and the core technology behind those systems, a proprietary design called VICTS, turns out to be unusually well-suited for handling the extreme power levels that high-power microwave weapons demand. ThinKom has already proven its VICTS phased arrays to gigawatt power handling in development and testing. The image that accompanied the CFW reporting tells the story efficiently. A VICTS-based HPM system finished in military olive drab mounted on the flatbed of a standard pickup truck in an open field. No trailer, no generator the size of a shipping container, no dedicated vehicle or specialized chassis, a truck system, and the ability to move. That portability is not incidental. It is the entire argument ThinKom is making about why its approach to HPM is different from what has come before. VICTS stands for Variable Inclination Continuous Transverse Stub, a steerable mechanical phased array antenna that ThinKom developed and patented for the satellite communications market, where most phased arrays steer their beam electronically, shifting the signal's phase across an array of fixed elements. VICTS steers mechanically, which allows it to handle significantly higher peak power without the thermal and efficiency penalties that electronically scanned arrays suffer at extreme power levels. Bill Milroy, CTO and co-founder of ThinKom, said at the company's market entry announcement in August 2025, "Building on our long heritage of ground and airborne SATCOM systems, we realized that our antennas are uniquely suited for handling extremely high power levels and are investing heavily to develop HPM systems for the warfighter." ThinKom pairs the VICTS antenna with traditional vacuum electronics to achieve what it describes as best-in-breed power density in a compact, steerable, low-profile package. High-power microwave weapons work by directing concentrated electromagnetic energy at a target, in this case an incoming drone, with enough intensity to damage or destroy the electronics inside it. Unlike radio frequency jamming, which disrupts a drone's communications link and can be defeated by autonomous flight modes that don't require a continuous connection to an operator, HPM delivers physical damage to the onboard electronics themselves. A drone that loses its link can loiter, return home, or continue its programmed mission. A drone whose flight controller, GPS receiver, or motor control electronics have been burned out by a burst of gigawatt microwave energy does none of those things. ThinKom describes the effect as a hard-kill defeat, focused electromagnetic energy that enters the target through antennas or couples with other electronics to cause immediate permanent damage at range. The 360-degree coverage and on-the-move capability that ThinKom emphasizes for EchoShield integration address a tactical reality that fixed-site HPM systems cannot solve. A system that requires a stationary platform to operate is useful for defending a base perimeter, or a fixed asset. A system that can track and engage while its host vehicle is moving can protect a convoy, a maneuvering unit, or a forward element that cannot stop without becoming a target itself. At the CFW, EchoShield's precise radar data cued the ThinKom HPM effector to incoming threats in real time, allowing the combined system to detect, track, and engage without the vehicle stopping or the operator manually acquiring the target. The integration effectively turns a pickup truck into a mobile directed energy counter-drone platform. The size, weight, and power metrics. ThinKom is targeting what the defense industry abbreviates as SWAP, matter enormously for a system intended to operate from light vehicles. Every pound added to the system is a pound subtracted from something else. Every watt of prime power the HPM system draws is a watt unavailable for communication sensors or other vehicle systems. ThinKom's VICTS technology consumes less prime power than electronically scanned arrays at equivalent output levels, which is part Of what makes the pickup truck integration physically possible rather than just theoretically desirable, the company describes the resulting package as ideal for both mobile and fixed-site missions. The broader counter-UAS market ThinKom has entered is crowded and moving fast. Kinetic systems, missiles, cannon, machine guns are effective but expensive per engagement and limited by magazine depth. RF jamming is cheap, but increasingly defeated by autonomous and GPS-independent drone designs. High power microwave occupies a theoretically attractive middle ground. Deep magazine, since there is no projectile to expend. Near-instant effects, the ability to engage multiple targets simultaneously across a wide area, and physical destruction rather than temporary disruption. The question that every HPM program faces is whether it can deliver those effects reliably at tactically useful ranges from platforms that deployed forces can actually operate and sustain. ThinKom's appearance at the CDF-CFWE with a system that fits on a flatbed and integrates with a commercial radar is an early answer to that question. Not a definitive one, but a visible one.